is a common emitter amplifier. Okay, and here to design this amplifier, we need certain thing like let's say this figure. So it is not so much clear, but also this figure helps us to understand more about CE amplifier. I would like to explain this figure. Here is the this one is the source, voltage source. Let us forget this for a while, and we connect from here. We'll make a circuit in breadboard from here C1 to this all. I will explain here what is happening. C1 will keep here one capacitor of 22 microfarad at C1, and from here we'll keep a resistor R2 that is a we'll keep a resistor R2 that is 100 kilo ohm, and here RE, oh sorry, it is 10 kilo ohm. Okay, R2 is 10 kilo ohm, RE is 1 kilo ohm. We'll keep this to resistor over here and we'll keep it ground. And this is a transistor. We'll supply this capacitor connection with the transistor, and this one resistance is actually its value is R1. Okay, this resistance has a value R1, and exactly its value will be, let me see for a while. This one resistance value will be 22 kilo ohm. Okay, this resistance will be the value of 22 kilo ohm. 22 kilo ohm. Kilo ohm. Okay, now after this, this R1 connection will be there, and we need to know about the color code of amplifier, which we have a formula BB Roy, Great Britain, very good wife, wearing gold silver necklace. Okay? From that we can take out our formula, and we can find this all resistance, and R1 will be connected with BCC, and here RC is there. That is the resistance which is connected with the collector of transistor, and here is C2. C1 is of 22 microfarad, and C2 will be of again it will be of 22 microfarad. Okay, C2 will be 20 microfarad, and from emitter we will take out RE, that is a resistance which is connected with the emitter to the ground. Okay, that is as value 1 kilo ohm, and from here same connection will be given to CE, that is emitter capacitor which is kept at emitter, whose value is 100 microfarad, and here I have made a switch. Why this switch is made? In some certain case it will be joined like that, and from here we'll measure a V output, but I have kept your switch because at the time of need of load resistance only we'll keep this. So for this purpose I have kept your switch. For your different kind of experiment, you may not keep your switch. Okay, you should not keep your switch, but it is just for the explanation. So this is the circuit diagram of CE amplifier. Actually, I want to say that CE amplifier is a common emitter amplifier. Okay, we call it as a common emitter amplifier. Common emitter amplifier. Emitter means this. Okay, common emitter amplifier. And after that, this is B output voltage. We can calculate over here. B in will supply over here. Okay, there is something which I need to say over here. Okay, B in. What type of voltage will supply here? Okay, we will take a voltage from the frequency generator, AC voltage. Sinusoidal wave will supply, okay, whose value should be in millivolt. So for this purpose, we need to apply some voltage divider rule here, because we cannot directly supply 2 volt, 3 volt, 4 volt, because its gain is amplifier have certain gain, and CE amplifier have a gain of 100. Have about a gain of 100. So if we supply here 5 volt, it will be 500 volt, which is not possible. So we'll reduce the voltage by doing something as a voltage divider rule. So after applying voltage divider rule, we'll divide voltage, and the voltage will be supplied here directly to C1. We'll forget this now for a while. Okay, later on we can do this thing. I'll come to this point later on. So we'll apply voltage over here by using a voltage divider rule. I have mentioned here, we'll keep 100 kilo ohm resistance on up, and down 1 kilo ohm resistance. We'll supply here BCC. This BCC will be from that, this BCC will supply it from frequency generator, and this BCC will be divided. Suppose this BCC have certain value, 12 volt, 13 volt, whatever. Okay. this BCC will be divided into 1 by 101 BCC, because this is the voltage divider rule. We know that voltage divider rule, if this is R1 and this is R2, then the voltage we can get here in middle is R1 divided by R1 plus R2. Okay, we'll supply this voltage over here, and the input voltage is set already. Now the current flows in the certain circuit, and after this, what I was supposed to say that when the current is supplied over here, its gain is about 100, and we'll see the output voltage in an oscilloscope. Okay, oscilloscope is a certain device, electronic device, which makes the process of experiment easy to get to digitalize our data. Okay, an analog signal to digital signal we can get through oscilloscope, and here from here we can get a V output. We can see V in and V out both in oscilloscope, and the main thing is that if V in is at some wave cycle, because it is a obviously it is a AC wave we give it as an input, and V out also have a same wave but opposite in phase. Can you see here? V output should have opposite in phase, and it should be amplified signal. Suppose I have made a V out in this form, but actually V out will be, I will have a form like this. Okay, because the amplification will be 100 times more than this one. Okay, 100 times it will be bigger, more bigger than the input signal. Suppose this is the input signal and this is output signal. Output signal will be more than the input signal, amplified version of input signal. Okay, I would like to erase this, whatever I have drawn here. Okay. Okay. So this CE amplifier is also known as an invert. Now next, we know about this voltage divider. We'll supply this to the input C1. We'll supply this voltage, this point, this arrow 1 point will be connected over here by bringing it to C1. We'll not connect this. This part will be removed. Okay, and we'll check the output, and we'll know the gain means V out by V in. Whatever voltage we get here as output, this. Whatever voltage we get here as output, V out. Okay, whatever voltage we get here as output, and whatever voltage we get here as input, will vary resistance from 1 to 10 kilo ohm. Will vary resistance, and we'll calculate here voltage. Okay, and we'll get some certain gain. Okay? In any value, we can take a gain. Gain will be equal to V out by V in. Obviously, gain means input voltage is converted to output voltage by what factor. That is called a gain. By what number it multiplies to give output, that is called a gain. This is the experimental gain we can get out from V out by V in. As I told you already, V out and V in can be calculated with the help of oscilloscope. Oscilloscope, we have some certain data in oscilloscope. At what point we have set that that matters in oscilloscope. Later on, I can talk about that, about the oscilloscope, a simple working mechanism of oscilloscope. After that, we'll take out the theoretical gain, because this is the experimental gain which can be taken out from, this is the experimental gain which we have taken out from experimental value by calculating V out and V in. Now another is theoretical gain, which can be calculated by the formula RC by small rc by RE. Okay, this one actually RC means the value is given over here. RC is 2.2 kilo ohm. 2.2 kilo ohm. Another small RC means I mentioned here current source resistance, whose value is very minimum, so we can neglect it, RC. So if we neglect it, then the value of A will be equal to minus RC by RE. So this is the formula for gain. So we cannot take out this theoretical gain easily because we don't know value of RE. Now what do you mean by RE? How can we take out this RE? The RE have certain formula, that is the value 25 millivolt by IE. IE means emitter current. IE means emitter current. That means the current which flows from emitter, that is called a emitter current. I can write here IE. So how to take out this IE? We have some problem to take out this IE which passes through this point. So for this purpose, we'll take out multimeter and we'll measure the voltage across this resistor. We'll get VE. Okay, we'll get the VE voltage across the resistor. If you divide voltage by the resistance, we can get the certain value for current. Okay, we know this thing. So input impedance, this one input impedance. Now we have taken out the value of theoretical gain and experimental gain. If there is some certain error, we need to take out that error through the process of error analysis. So input impedance, now it is a term for input impedance. How to take out the input impedance? For this purpose, we'll connect the signal. Okay, we have prepared the voltage divider. We'll connect voltage divider to a 100 ohm resistor before connecting it directly. Before connecting directly it with 2.2 microfarad, 20 microfarads. Sorry, let me come here. Here directly we have some connected this voltage divider to 22 microfarad, but for the case of input impedance, we'll connect here 100 ohm resistor and we'll connect the voltage divider on this point like before. Nothing but between these two, we'll connect here 100 ohm resistor and we'll measure the voltage on A and voltage on B with the help of oscilloscope BA, BB. And after that, we can get the input resistance as a BV divided by BA minus BB multiply 100 ohm. Why this 100 ohm? Because 100 ohm is kept over there. Okay? It is the preferred value for resistance in case of CE amplifier. Okay. Theoretical gain can be calculated by this formula R1 parallel R2 beta plus 1 RE. We know here value of R1 R2. R1 value is given here. R2 value is given here. Okay. RE also value given, whatever the value we need, we can be given here. So here the value for beta. Okay. Beta is the value which comes directly from the transistor. Okay. Transistor, we can check in a multimeter also. There is a point to check for transistor. If you keep a transistor over there, it shows a certain value of beta. So if we, every time we cannot check, so sometime for NPN transistor, which we have used in our experiment, I have shown here as a figure of NPN's transistor, which has a code BC547. BC547 is the code for NPN transistor. So now what can be done is this beta value, 1 value, and RE value. RE value already taken out from here. Okay. This all value will be kept over here. Beta value can be preferred 299 or 300, whatever. But for this case, if we take 299, it will be equal to 300 by addition of 1. So this is the theoretical gain, and experimental gain. It should be, the values should be nearby with each other. Similarly for R out, that is output impedance, we'll calculate E naught and BL. How to calculate this E naught and BL? So for this output impedance, we'll keep here. Value of RL from 1 to 10 kilo. Whatever we can keep, 1 to 10 kilo. And at first, we'll remove this load resistance. Okay. At first, we'll remove this load resistance, and after that, we will take out the value of B naught. And without load resistance, the value which we take out from here will be E naught, small E naught. And after load resistance, E naught and BL can be calculated, and experimental value can be experimental value for not by BL minus 1 multiply something ohm. Whatever ohm we will keep for the value of BL, which that can be shown over here. So another nearly unity voltage gain. Oh, this one is for another purpose. So this one is for CC amplifier. Okay, experimental value can be found from here, and experimental value and theoretical value should be coincide with each other. So theoretical value can be taken out with this formula, RC by RC, small RC. We know small RC value is very, very small. So this value will be similar, nearby, equal to RC. So I hope you are clear on this CE amplifier. You all are clear on the CE amplifier. Okay, one thing I forgot. Before doing anything, at first we'll supply here voltage divider, and we'll check each and every output voltage by varying this resistor, and we'll note this all in tracing paper. Okay, and our CE amplifier work will be over. I hope you like this video. If you have any comment, feedback, then you can just give feedback to me. Okay, thank you very much.